and then we'll, I usually try to leave that off the recording in case people have things they want me to pray about. But we'll pray for our week, and you have an exam coming up on Friday, so we should pray for that. And I understand that if you're an engineer, you have multiple exams this week. 4? Well, someone was complaining they had 4. I don't know who that was. Someone in calculus. So, yeah. All right. Well, let's go ahead and pray. Thank you for this day, Lord. Thank you for this class. I pray your blessing upon these students. Grant them insight and understanding, and help them to find your truth written in the language of statistics. It's in your name. Amen. All right. I forgot to pray for the exam, but I will as you take it and as we go through our week. So I have a quiz here. I gave you back the quiz from last time, and I just want to mention a couple of things just to remind you to just be careful with this in terms of being precise with your language. So, for example, the claim should be written in the actual body of the problem, and make sure you use the right symbols. Remember that means are mu and proportions are p, so you've got that squared away. And of course, hint, hint, your homework was on proportions. This one's on proportions as well, but on the test, you'll have to sort it out. So use a p. I don't want to see any mu's. And then let's see, a couple other things that you guys or some people had trouble with on the quiz last time is the decision is always going to be reject the null hypothesis. So reject H sub 0. Don't give me just reject. A couple of you did that. So hopefully you can get that out of your system now. So on the test, you won't do it. Welcome. So remember, reject. What are you rejecting? So tell me what you're rejecting. And then the conclusion. I know I didn't give you the template last time like I did the previous time. So the time that I gave you sort of the fill in the blanks, everyone did great. Last one, not so much. So just to remind you, there is enough evidence to suggest the alternative, or there is not enough evidence, and make sure you write the alternative hypothesis in plain English. So hopefully you're good with that. I didn't see any big issues with the Newton, but of course you're just clicking there and selecting, and you may not even be reading fully the sentence. So, so this will be good, hopefully, for the exam. Were there any issues or questions with the homework that you want to talk about before we do this? So give it a go. Okay, let's go ahead and try this one. So hopefully it won't be too. I can't see it because of my glasses. Let me make sure this is the right one. They all look alike. Okay. Yeah, this looks good. Okay, 1, 2, 3. Yeah, sure. There may be 4 there. If there are, you can pass them back. Here, I'll give you another one just for fun. If there's not enough, I'll come back. There's 2. I'll give you 1 more. There you go. 1, 2, 3, 4. Sure. Here's 1. Yep. Yeah. 1, 2, 3, 4. Come on, buddy. There you go. 1, 2. Uh-oh. I think I gave out too many up front. I'm coming back. You need. Thank you. Enjoy. See if I can dig this out. Not that. Come on. Come on. What's this? you go. That might help you. Just the symbols there. Yeah, you got it. Oops. So much to write. I guess one guy just got up and left. So if you are done, I'm happy to take a look. It just, that last one, you have to write a whole sentence. My arm started getting hurt. So hopefully you have stronger arms than I do. But yeah, feel free to pass your paper over if you're all set. I guess front row, I can just grab yours if you don't need to medicate. Okay. All right, very nice. Good job. Thank you. Beautiful. You're all set? All right, good. Nice work. Job. Take your time, but try to hurry up. Just kidding. You're all set? You got a nice sentence? That looks good. All right, good job. Nice. Good job. Oh, is this an extra one? I gave you too many? All right, I'll give this to someone who isn't here today. Save that for later. Oh, there's one there. All set. Nice, nice symbols as well. All set. Nice, nice sentence. Very good. All right. Oh, don't erase too much. You can use abbreviations. It's okay. Does that look good? Okay, good. All right, I think I've got all of them. Anyone holding out on me here? Oh, I'm sorry, Kirsten. I didn't see over there. You're all set? I'm not rushing you. Good. All right, great. Let's do this. Staple it together. Ugh. Oh. Okay, so let's see how I did this. So first things first, we have the claim. And so let's see, Wonka believes, wait, I got them all right. Okay, believes. So anything you see that or you see the word claim or something like that, you should zoom in like, oh, that's what we need. A larger proportion of kids from Bavaria will try to drink chocolate than those from South America. So you're going to have proportions. Proportion is written right there. So here's what I have. P1 is greater than P2. I suppose I should have, well, it's pretty obvious since it actually says the numbers here and the X1 and N1 that from the table, sample 1 is the Bavarians and sample 2 are the South Americans. Anyway, pardon me. I've got my proportions. So if you're thinking like, did I do it right? Here's what I'm looking for is I'm looking for the P and the greater than P2. So that's pretty straightforward. Here, you need to have all of this. So you need to label these and you need to have this. Now, of course, as before, you could have an equals instead of just a less than or equal to. It's fine there, but you have to have these sorted out. So all of those symbols, I know there's a lot of them, but you'll get used to this, and hopefully on Friday, everyone will get an A. It's good to get if you didn't do the last one correctly, it's good to get that out of your system. That's why I give you the quiz, because it's worth almost nothing. So that way you can do it well on the test. This one is right-tailed, of course, because of this. The alpha level is given. It's always going to be up here somewhere. And here it's like that, the 0.1 level. So anytime it says something like that, you know that's alpha. That's your cutoff. Whoops, I went too far. Test statistic and p-value, you'll be able to find them right up here. So look at that, it's even labeled. If you got that one wrong, then shame on you. So that'd be really sad. Yeah, maybe I should change. I took the spreadsheet that we made on Friday and I just took a screenshot of the one thing there. So maybe I'll delete that before I make the one for Friday, just so that it's a little bit harder. But anyway, the p-values, once again, that's pretty straightforward. And it's a little challenging for me to sort of track with you. I tried to do this with the quiz that I gave back to you just now, and that is to say that if you think that this is left-tailed, then you should be picking the left-tailed p-value. But hopefully most of you realize this is right-tailed, so we're going to pick the right-tailed p-value. There it is. And so there it is. And of course, that's so small. That happens to be way less than alpha. And so you're rejecting the null hypothesis. Once again, I'm looking for those symbols. I don't know. I mean, you could probably put other stuff here, but you pretty much have to have something about rejecting and something about H sub 0. So might as well just write that. It's not that hard. This is the hard thing. And even this, I was a little bit terse. So there is evidence. So here's what when I'm reading, and I have to read, I guess there's only 24 of you. I've had times, like there have been classes where I've had 48. That's a little bit more challenging to read that many. But so there is evidence. I'm looking for that to suggest. And then I'm looking for something that here that is the alternative hypothesis. So just tell me in your own words. It doesn't have to be exactly like mine, but mine is kind of, I don't know, not the best, but the proportion, so we're dealing with the proportion of Bavarian kids who drink chocolate is greater than the proportion of South American kids, and I got lazy there. So something to that effect, and you'll do fine. So I'll give this back to you on Wednesday, and then you're all going to get this perfectly correct on the test on Friday. I can't wait. All right, we need to move on. One more hypothesis test before Friday. Last one, and this one is called the paired t-test, but it's kind of a rehash or a mashup. I don't know. I don't know what the cool kids say these days. But here it is. Just a minute. I need to be able to see everything on my screen. Okay, I can see it all. So this is called. It's the test. It's the two dependent samples. So the key here is that you have two samples. So it's going to feel similar. Two samples. So you're comparing two populations, but here's the difference between what we have been doing. So this is the old way, the stuff we've been doing. So this is last week, and this is this week. So last week, the two samples were unrelated. Related samples. I'll show you a picture of this in just a minute. This week, they are related. So that's the big difference between what we're doing this week with what we were doing last week. Now, how are they related? Well, that's the thing that you're gonna have to figure out. But here's a couple of pictures that maybe will help. And some examples, and we have a whole bunch of examples where you're gonna tell me, are they related or are they unrelated? That's gonna be the big hang up. The rest of it is easy. So dependent sampling is this. You're gonna have two samples that come from the same source. So you have the same source that you're getting the samples from. This is the sort of thing that you would have if you have before and after, like if I gave you a pre-test and a post-test. This is common practice in education, is that we'll give students pre-tests and then post-tests, and we'll say, did they learn anything? And we'll compare the pre-test with the post-test. Because certainly if you get an A on the final, it doesn't mean that I've taught you anything. It just means that maybe you know it all, and maybe you knew it all before you came. Okay, so that's dependent sampling. Here's a picture of what that looks like. We have a sample, it might be you, and we have two variables that come from the same sample. So you have the pre-test and the post-test, and we're comparing the two. But there's a relationship between those two. The relationship is you. Each of you would have a pre-test score and a post-test score. So that's the sort of thing when we talk about dependent samples. This is the opposite of dependent is independent. That's what we did last week. So this over here is this week on the left. On the right is last week, just to illustrate. You have unrelated sources. So you have two samples. There's a big line between the two. So you have two samples that are unrelated, other than the fact that maybe it's your class compared with the 9 a.m. class or something like that. There have been semesters where I've taught statistics to two different sections. I always love that because then I can say, hey, you're the best class. I mean, you are the best class, but I would have someone to compare you with and say, look, you're better than them because you're getting better grades, and I can show you. But certainly you're both students. Both classes are students. You're both taking statistics, but you're different groups of students, unlike here where it's the same group of students giving me both scores. So an example of dependent sampling, you might have a pre-test and a post-test, as I mentioned. You might have husbands and wives. This is common. Like if we want to compare, I don't know, you could say compare the IQ scores of husbands and wives to see, is there a relationship between, this is the sort of thing that might be interesting. Or income levels, stuff like that, ages. Side-by-side product testing, you go into a store and they're like, here's some soda that is brand A and here's brand B. Tell me on a scale of 1 to 10, how do you feel about that? How do you feel about this? So those are the sort of things that you might see as dependent samples. Now there's another way to get dependent sampling, and that is if you have two separate samples, but if you can somehow connect those two samples by some means, you can get rid of this bar between here and actually create a connection between those two. So the way, when that happens, we call that matched pairs sampling. So one way to think of this is, let's say that we are comparing dieting with exercise as a weight loss technique. And we have two samples. We have a sample here, they're all gonna do dieting, like just counting calories, and then these people, they're not gonna worry about calories, they're just gonna exercise a whole bunch. So we wanna compare which one is a better technique to lose weight. And so what we could do though is we would match up the 300-pound kids from this sample and this sample, and then you've got a 200-pound kid here that gets matched up. So if there's some way to match up the people in the samples and say, okay, we're going to compare the skinny kid with the skinny kid over here, and so if you can do that, then you can essentially get rid of that bar between the two, and suddenly this thing is now connected. So that's another technique that's commonly used, is if you have unrelated sets, but you create a relationship based on some sort of a variable that makes sense. With weight loss, it would make sense to compare skinny people with skinny people and chubby people with chubby people, and I count myself in the latter group. So I'm not making fun of any of you. I'm just thinking of myself. I do need to lose a little bit of weight, I think. It's been a stressful year, and I generally eat when I am stressed. So yeah, there's been a lot of Vienna fingers, those little cookies. I love those. But anyway, getting back to this, once you have that connection, whether it's through dependent sampling or through matched pairs, suddenly the calculations become much easier. But before we get to those calculations, and they do, we don't need another spreadsheet, by the way. We already have I'll show you. We already have all the stuff we need. No new calculations today. But we do need to be able to sort out when we're dealing with matched pairs, rather dependent or independent. So that's the question here, is this a dependent, wow. Sorry. Let's try again. There, is that better? I did bring tea. It does have my favorite derivative, which is 1 over 1 plus x squared. Okay, but anyway, are these dependent or are they independent? And question mark. Okay, so I'm not going to write that on every one of these because there's a bunch of them, but here's the little thing. I'll read it over. Researchers are looking to determine whether more students throughout a state prefer to bring lunch to school as opposed to purchasing it. One random sample is taken from students at a certain school system where the students are asked whether they prefer to bring lunch from home or to buy lunch at school. A second random sample of students from a school system in a different part of the state are asked the same question. We're comparing the two different school districts. So is that dependent or is it independent? Ooh, let's see, I didn't even set this up. So you think about it, you pick one of those while I'm getting myself set up here. Manage, just a sec, random. Okay, got it. Okay, Gracie knows. Gracie, which way, how do you think of this? It is independent because you have these two schools. Here's school number 1. So I don't know, is that a school? That's supposed to be like okay, whatever. I don't know what that is. And then here's the other school. And so you've got all these kids at these two different schools. There's no relationship between those two schools, so that is independent. Very good. Let's take a look at this next one. Researchers are going to test whether the majority of 6th graders prefer playing soccer to playing baseball. One random sample is taken from 6th graders at a particular elementary school, and another random sample is from a different elementary school. So is this independent or dependent? Take a minute, I'll pick a rando. Oz, what do you think? Are these independent or dependent? It is also independent. It's almost exactly the same picture. I won't attempt to draw a school again, but yeah, you have these two schools, and it doesn't really indicate that there's any relationship between the two. So we'll say that this one is independent. We'll come back to these just to explain how we're going to use these facts in a minute. But let's go on to this third one. A research project is constructed to determine whether a caretaker's love of cooking has any impact on a student's desire to cook their own meals. To determine this, researchers choose adults who proclaim a love of cooking, that's sample 1, and then ask a student in their household whether they could see themselves cooking meals for their family someday. And that's sample 2. So you understand we have sample 1 are the caretakers, sample 2 are the kids. Are these independent or dependent? Kirsten, what do you think? These are dependent. What's the relationship here? Okay, so we have this is a caretaker, here's some kid. So there's a relationship there. Here's another one, and this is going to be, yeah, here's another kid. So each adult has a kid, and you're comparing the sample of adults with the sample of kids, but each kid has an adult, each adult has a kid, and so there's a relationship there. Very nice. So this one is dependent. One more. Pharmaceutical company is testing whether or not a new medication will decrease cholesterol. The company randomly selects 50 patients And before any medication is given, the cholesterol level of each patient is measured. Then the patients take the medication for 60 days, and the cholesterol level is measured again. So, independent or dependent? All right, Avery, what do you think of that one? Dependent, what's the connection? It is, it's pre-test, post-test. So each of the patients, that's the connection between the two samples. Very nice. So here you have this one, each person is like, here's before and here's after. So very good. So they're participating in both. So you get this, each person gives a sample, a blood test or whatever it is. So this one is dependent. Okay, let's take just a quick peek. Well, I've got some examples where we can actually do them because we have numbers. But before we do that, I want to show you my hypothesis test gold spreadsheet to show you what you're going to do. Okay, let's click here. For your homework. So here's the deal, is when you have, go back to the top here. So it's so hard to see at the bottom. Oh, these are proportions. So here's where we're focused. We're on these three down here. No, got to go over one more. There it is. One mean, two means, and the other one is two means as well. Okay, so getting back to here, we'll toggle back and forth for a sec. So back here, when I look at these pictures, whoops, there we go. Let's get rid of those words. I guess I have to have that. Okay, when you have dependent samples, essentially what we're going to be doing is we're going to treat these dependent samples as a single sample. So what you'll do is you'll take differences, so you'll compute differences, and then use the one mean tab. So that's, yeah, it's back there. The one that I had open. You use the one mean tab. I'll show you this. So you might be thinking, what? What do you mean? Well, basically you have your two variables. Let's just think about the pre-test, post-test thing. You have the pre-test, post-test. I'll do the difference between the two. We'll do post-test minus pre-test. And I'm hoping everyone has a positive number when they do post-test minus pre-test, because that would mean you've learned something. So we'll do that, and then we'll compare the average of those numbers. So essentially, you're taking two samples and cramming them into one sample. And so you use the one mean. When you have the independent sampling, that's the two means. Two means, and then you have to worry about whether you have the same, different, or different standard deviations. But all of this stuff you do for homework for today is this one. I'll show you an example in just a minute from, Newton. First of all, though, we'll do a simple example. This is one that you can do as well if you really want to, if you want to pull up your version of this. So, but you don't have to, because it's such a simple example. I just wanted to show you this. So here is a really short, I know it's such a small sample that it really wouldn't be a good to do. You always want a sample of like 30 would be much better, but just to make things a lot easier, I picked just 4. Well, technically there are 8 people here. And what I've done is I have, this is the idea of comparing weight loss of dieting with weight loss with exercise. So these 2 people began with an initial weight of 250 pounds. So I found 2 students that weighed 250 pounds, roughly the same height. I know, we got to get similar BMIs, that whole thing. Maybe that's what I should have, is the BMI instead of the weight, but whatever. This is all made up, at least for now. So I've got the dieter lost 40 pounds, the exerciser lost 50 pounds. I don't know how realistic that is, but let's just say that that's through the whole course of the study. And then I have two students that each started out at 175 pounds. The dieter lost 10, the exerciser lost 20, and so on. So remember, what we're going to do is we are going to compare the difference. Now, this is super important, is I need to difference. Okay, so the difference, I need to be very specific about the difference because it's going to affect the hypotheses. So here's how this is going to look. I'm going to actually specify, I just realized, okay, good. I wanted to see if I had my mic on. I have to specify what my difference is. So I'm going to do exercise minus diet. So in other words, it's going to be this column minus this column. If I did it the other way around, there's nothing wrong with doing it the other way around. It's just that the whole hypothesis test will be backwards. Nothing wrong with it. It'll just be you'll be left-tailed instead of right-tailed or whatever. So let's do it this way, and then we'll see how things shake out. First of all, I need to actually specify my hypotheses, my claim and my hypotheses. So I claim that exercise is better than dieting. And so what I'm going to say is this, that my claim is that when I do this, exercise, I guess, is with an S, that my claim is that when I do that, the average of those differences will be bigger than 0. Now think about what this means. If the average of these differences is bigger than 0, it means that these numbers largely were bigger than these numbers. Now sometimes they'll be the same, sometimes this might be smaller, but on average, I think that these numbers will be bigger, that people exercising will lose more weight than people dieting. So now I just want to point out, I'm just making this stuff up, all right? So I believe there are some studies that actually demonstrate that there is a benefit from exercise. I think the best thing to do is to cut calories and exercise, but that's neither here nor there right now. It's just an example, so don't take this as the gospel. Okay, so let's do the null hypothesis and the alternative. So I know it's kind of, whoa, 2 colons? We don't need 2. So go ahead and jot down what you think the null and alternative hypotheses are using that symbol. Notice I've introduced a new, I know the mu you're used to, but the little subscript, the D, just means the average difference. So take a minute. I'll pick a random person. It'll be fun. There we are. Sienna knows. Sienna, do you know what the null or alternative, either one, is? So diet is less, which is this right here, right? That's the, so I know you just don't want to have to say that symbol, but you can write the symbol, right? Yeah, so it's mu sub D. I'll do it for you, don't worry. So that's the alternative. Mu sub D is greater than 0. That would be the same as saying that dieting is less than, because this minus this is bigger than 0, so that must be smaller than this. Very nice. Okay, let's get the, now that we've got the alternative hypothesis, let's get the null hypothesis. August, do you know what the null hypothesis is? Very nice. So mu sub D is equal to 0. So, and if you want, you can also just write that as less than or equal to. It's okay either way. I think Newton, though, is always going to have it just be equal. But when you do Newton for tomorrow or for Wednesday, you're going to see it's all mu sub D. So there's going to be a bunch of those symbols. Okay, so we've got that sorted out. Let's see, this thing, right-tailed, left-tailed, two-tailed. Will, what is this? Left-tailed, right-tailed, two-tailed? It is right-tailed. Very nice. So, so the way, I don't know what you're doing with your hands here, but if it works, it works. I always use that symbol on the alternative hypothesis. It looks like an arrow pointing that direction. So I think, oh, right-tailed. So whatever it takes is good. So this one's right-tailed. That's going to be important when we look at our p-values. And then we need an alpha level. Alpha, you know what? Let's let you pick. Anna, what would you like for our alpha level? I don't care because it's not given here. Yeah, 0.05. Okay, so that's what normal. So you're picking the normal, the gold standard, which is good. I would have been happy with anything, you know, to pick 0.1, 0.01, 0.02. Since it wasn't given to us, just pick something for now. It'll always be given to you on the homework and on the test, so don't fret. I'm not going to make you pick one. Okay, we need to actually compute this now that we've got there, because the next step is to actually go to Excel. Before we go to Excel, here's what I need, is I need these differences. So these are the differences. 10, I'm just subtracting. 50 minus 40 is 10. 20 minus 10 is 10. 30 minus 20 is 10. And then 40 minus 20 is 20. Okay, so there's my data. And here is my spreadsheet. And I need to move my spreadsheet over so I can see my data. Hold on a sec. Okay, so let's see. There we go. Let's see. Can I just slide this? Apparently not. Okay, I've got to, just a sec. I got to grab something. Here we go. This will be fun. Okay. I just need something to be a stand-in there. Now I can get rid of this. Oh, there, that's better. Okay, so now I can see this is my hypothesis test gold. You're going to be using the one mean, which I think is the very first tab we did. That's what we're going to be using today, and for the homework for Wednesday as well. Over here, I'm just going to type in these numbers so that I have them, 10 and 20. And then we need the average. This is equal to the mean. Oh, no, average, because Bill Gates didn't know what the word mean meant. And then the standard deviation dot S of these things. There we go. Okay, there they are. Oh, wow. 12.5 and 5. Oh, how did that just is there a formula? How did that just automatically change? Did it change? It was like that to begin with? That's so weird. Sample size of 4? That's freaky. Really, was it really like that? Maybe I had practiced it earlier. That is so strange. Okay, well, anyway, there it is. That's so strange. I mean, normally you would have to type it in. Yeah, that's so weird. Okay, well, anyway, null hypothesis, 0. It's the same as what we're used to. Test statistic, we've got here. Okay, great. We've got our left-tailed, right-tailed, two-tailed. So the p-value here is 0.77. I'm going to write this down. So p-value is 0. Right-tailed 0077. Test statistic is 5. That's so strange. Is this stuff right? I don't trust it now. Man, I want to, just a minute. I'm going to shut this. Oh, but it's going to auto-save. I was going to close it and not save it. Well, now I've got to open it up again. Sorry about that. There it is. It's just a little weird. Okay, well, here it is. Yeah, I really don't need it anymore because I have all the information I need back here. Okay, so p-value, very nice. We've got our p-value. Now we just have to decide, are we rejecting or failing to reject the null hypothesis? Abby L, you know, compare this p-value to that alpha level. Are we going to reject the null hypothesis or fail to reject it? You're rejecting it because the p-value is less than alpha. Well done. Let me pick this with a nice, here we'll do black. So we're reject the null hypothesis. And then there is evidence to suggest that exercise is better than diet in terms of weight loss or something like that. Just give me, I know I probably should say the average difference between exercise and diet is greater than 0, but I'm happy if you just sort of point to what we're studying. You don't have to be super precise, especially if you say there is evidence to suggest. That makes me super happy. Okay, that's great. So we've got this taken care of. Let's take a look. I've got a couple other examples here, but they look boring. Let's take a quick peek at the stuff that you're going to be doing. Let me just pull this up. Give me a sec. Preview. I'll pull it over so that you can enjoy seeing it as well. There it is. Do this, and we'll do this. Which one is it? Where did it go? Is it this one? Hypothesis. Yeah, that's the one. Okay, good. Okay, so just to show you how this works, I'll zoom in because you can hardly see it in the back. But just you're going to see stuff like this. So notice that we have alpha. It's already given to you, and we're comparing sugar content from store brand and name brand cereal. So you know how it works. You go get Fruit Loops and you get whatever, Fruity Rings or whatever, you know, the store brand one, Kroger brand, the Raisin brand. You can get Post Raisin brand or Kroger Raisin brand, that sort of thing. So that's what we're doing here. We're going to compare sugar content between each of those different types of cereal. So we've got these things paired up, and they give you the stuff here. Oh, what is the question? Mean difference between the is less than 0. Okay, so they're doing name brand minus store brand or the other way around? The true mean difference, I need to make sure. See, this is where you got to read. Just, oh, here it is. Subtract, it'll tell you, subtract sugar content of the store brand from the name brand. So they're saying take store brand, name brand minus store brand. So it's 15 minus 13, 14 minus 16, and so on. So that's what they want you to do. Okay, oh, wow, they go right to that. Okay, well, let's find out. So here's how I would do this one. And some of them actually have you fill in the p-value and the test statistic. You know how that works. But I guess we're just going to cut to the end here. So copy and paste. So we'll copy this and paste it. Let's see, paste it here. There it is. I'll make this bigger. We'll come back to the other one in just a minute. So we have our pairs. So what you're going to need to do is you're going to need to compute the difference. So the difference is going to be here. So this will equal, I think they said name brand minus store brand is what we need to do. Here's a little trick you can do once you have all your data. If you can see this little square here, that's called the handle for that little cell. If you double click, I don't know what, well, I guess that would work on Macs too. But if you can get this to be like this, double click, there it goes, all the way down. Look at that, the whole thing. Okay, so now I can just find the mean. I guess I can cheat here and do the mean. That's column G. So the mean is equal to, hold on a sec. Go back so we can see it. There we go. So this is going to equal the average, average of G colon G. Okay, that's better. And this is going to equal the standard deviation of G colon G. And this is going to equal the count. Now, if you do this on your spreadsheet, then you just have to bear in mind that if you put new data in there, you may have to change some things. Okay, so here we have the test statistic. You have the p-values. And I believe that the hypothesis is that this number will be less than 0. And so when we got our test statistic, it's less than 0. Let's see, less than is left-tailed, isn't it? A less than symbol is over there. So less than is left-tailed, so that's this. So my p-value is 0.14. That is bigger than alpha. Alpha was 0.1. So I'm going to fail to reject the null hypothesis, and there is not enough evidence to suggest the alternative. So let's see if I can find this. Not the first one, could be the second one. Oh, we have to select more than one. So I guess it's going to be the second one because we failed to reject the null hypothesis. And then let's see, there is not enough evidence. So yeah, I can see why you would not necessarily read the whole thing, but try to at least internalize this idea that you want to have a sentence that includes the description in plain English. I mean, if you want to put that in your conclusion, you can, but so there is not enough evidence to suggest that, to conclude, they say, that the true mean difference between the sugar content of name brand cereals and store brand cereals is less than 0. So there's that. Here we go. So let's submit. Am I got it right? I hope so. Yes, I'm doing great. Let's not, I just want to see if the next one is any different. Oh yeah, so the next one is more like the ones you've had before. I won't go through this, but this one you're going to have to go through each thing and hopefully get them all right individually. Okay, so I think you've got enough to do your homework. We need to talk about one more thing, though, before you pack up and leave. And that is that you have one more project to do for me at some point. And I don't remember when, let me find this here, projects. I haven't graded your last project, but I will this week. Don't fret. Let's see, it says it's due, it's a long time from now. But I want to point it out because you have all the stuff you need to do Baby Project 2. So I just want to remind you of the genesis of the Baby Project. My mother-in-law claiming, and she to this day still claims that this is true. Like there'll be a full moon. Well, there are going to be a lot of babies born up at, she worked in the neonatal unit in the 60s, so she knows. But anyway, and I have data. I have data from the 60s. But anyway, getting back to this. So that's the genesis, is that my mother-in-law thinks that more babies are born during a full moon. So for this one, so the first one, you did a great job, I'm sure. Like I said, still going to grade, but I'm sure everyone got hundreds. If you did it, and if yours looks like mine from the video, basically you'll get 100. So same thing with Baby Project 2. You have a similar deal where I have a series of videos you can look at, but here you're going to be comparing full moon versus not a full moon, or something like that. Now, just so you know, there's the playlist here. I won't bother clicking that, but that shows me doing the project. This is the baby data. Some people were like, where's my data? And I was like, okay, it's right there. That's the actual data. And then here is the assignment. So when you click on this, you'll be able to figure out what you're supposed to do. So for example, where's it? Oh, here it is. So for example, here I am down here. I did, because I didn't want to change what I did last semester, I do 7, which I believe corresponds with Saturday. So I'm only interested in babies born on Saturdays, and I did full moon versus neither. So that was what I was comparing. You'll see me do this in the video, but if you're up here, let's say that I know no one's that person, but if you were here, you would do, let's see, Thursday. So you would be interested in babies born on Thursdays. And the reason why I've divided it up by day is because, as you probably noticed, or maybe you didn't, I think I mentioned this, is that moon phase has nothing to do with babies being born, but day of the week does. There are fewer babies born on Saturdays and Sundays than the other days. I think Tuesday is a big day. But so this would be Thursday. You're doing new moon. New moon is when you can't see, like, I think, let's see, is there a new moon? It's either today or yesterday. It's pretty soon. It's right around now, but versus neither. So there's the what you're going to be comparing there. No, I think the new moon is this weekend. It's because there's a full moon the day before Easter this year, I think. I don't know. The Easter is always based on the full moon. We'll talk about that later. Not to worry. I'll give you all the formulas. Okay, so you find yourself in this thing. Find what you're doing. You can see, look at all those happy people here. Wait, are these you? Those aren't you. Okay, I will, apparently I didn't upload the correct one. Okay, good thing I checked. I'll upload the correct one. I have another one with your names on it. But I'll upload the correct one, and then you can get started. So maybe I'll do that right now, since we do have a couple more minutes. We're done a couple minutes early. You can go get an extra serving of eggs.